titanium dioxide. Okay. So I have forwarded some pages to you. I have forwarded some pages to you. First, you can refer. There is one diagram. Can you refer it? Sulfate process. Sulfate process. Can you see that?
Yes, sir.
Yes, sir.
So, manufacture of titanium dioxide is quite a complicated, complex process. We start with the ore ilmenite. Ilmenite means from mountains. Mostly it is occurring in Kerala, then Norway, Canada, China, and few other countries, and it is a black sandy ore. Okay. So first stage, when you receive this ilmenite ore, subject it to fine grinding. You can write down, please write down the information. That is more important. Always remember that when you write down the thing, they are printed in your mind and heart. And if you don't write, everything is washed off. So please have a notebook and try to write down. So what is the first stage? Ilmenite is crushed to fine particle size in automatic grinders. And then after that, it is subjected to drying. The dried powder is dissolved in oleum. What is oleum? Oleum is fuming sulfuric acid. Oleum is fuming sulfuric acid. The formula is given below. Two molecules of sulfuric acid combine and form oleum. Strongest acid. To give you a brief history about this step, earlier we used concentrated sulfuric acid only. But there, it was a very violent reaction. Lot of fume and temperature rise was there. So naturally, this has been replaced by oleum. So it is just dissolution and no hazardous intense reaction. Oleum just dissolves this ilmenite. After dissolution, the next step is first you add sulfuric acid and then add slowly water. This ilmenite is iron titanate, means a composite of iron and titanium dioxide, iron oxide and titanium dioxide. So when you add sulfuric acid, oleum or anything, everything gets converted into a sulfate. Just see the diagram. Do you have on your WhatsApp, can you see?
Yes, sir.
So you get titanyl sulfate, ferrous sulfate and ferric sulfate. These are the products. TiSO4, ferrous sulfate and ferric sulfate. Now we are not interested in ferric sulfate. because it creates a lot of problems. So to this solution, we add scrap iron. We add scrap iron. This will convert ferric sulfate to ferrous sulfate. So in solution now we have titanium sulfate plus ferrous sulfate. Titanium sulfate plus ferrous sulfate. Okay. Subject this to evaporation under vacuum. Subject this to evaporation under vacuum. So ferrous sulfate will be separated, and what remains is a solution of titanium sulfate. Try to understand this point, that there is a composite with us of titanium sulfate and ferrous sulfate. So what we are doing, we are removing ferrous sulfate and getting a clear solution of titanium sulfate. Okay. Next step. Next step, this titanium sulfate is subjected to hydrolysis by boiling with water. When you heat titanium sulfate by boiling with water, you get titanium tetrahydroxide, TiOH4. TiOH4. This is filtered. A dry white spongy mass is collected. This is dried and it is calcined in a rotary kiln at 800 degrees Celsius. Try to understand, very simple. When you get titanium hydroxide, then what you do, you filter it out, you dry it, and then send it to a tubular heating reactor. So raise the temperature to around 800 degrees Celsius. Your titanium dioxide is produced. Titanium dioxide is produced. Hello?
Yes, sir, you are audible.
After getting titanium oxide, now it is necessary to have coating. Some surface treatment is essential for titanium. Some surface treatment is essential for titanium. Just a minute. अरे वैभव इकडे ये जरा. कागद याच्या खाली गेले सर. अरे मी खाली पडल्याबरोबर ते खालीच गेले. नाही मिळाले. So why this surface treatment is essential? Because by surface treatment we improve the compatibility and emulsification of pigment with the binder. That is how we make titanium dioxide. Finally, it is dried, powdered, and packed in bags. Now try to understand the thing. I will repeat once again the whole process. Okay? Try to understand each step. First stage is ilmenite. Raw ore is coming from the mines. So this ore is first subjected to fine grinding and drying. Okay? This dry powder is then dissolved in oleum. Oleum is fuming sulfuric acid, very strong acid, so it can dissolve ilmenite. Earlier, we were using sulfuric acid, but that created a very violent reaction, temperature rise, etc. So oleum will just dissolve because of its strength, and we will take it, we will add sulfuric acid and water to it. Ilmenite is nothing but iron titanate, means reaction iron oxide and titanium oxide. Iron titanate. So this will get converted to titanyl sulfate, ferrous sulfate, and ferric sulfate. I think you understand it. Okay, second step. Now you have to treat it with scrap iron. Why? Because we want to convert ferric to ferrous state. Therefore, we add scrap iron heat, so we get now titanyl sulfate, and all ferric is converted to ferrous sulfate. Okay? This is subjected to vacuum evaporation. So water is removed and this iron sulfate will separate out. Titanium sulfate solution will be there, and this ferrous sulfate will separate out as a precipitate. This solution of titanyl sulfate is filtered, then it is subjected to hydrolysis. Heat it with water. By heating with water, you get titanyl tetrahydroxide. It is a fluffy, spongy mass. You filter it, dry it, and then calcined in a clean or a tubular reactor, which is at 800 degrees centigrade. So here it will get converted into titanium dioxide. The control of temperature, the time for which it is to be kept, that is very critical. If the temperature, the reaction conditions are maintained, we will get excellent particle size of titanium dioxide. The whiteness, brightness, and other properties of titanium dioxide will also depend on correct execution of this particular step. After that, we subject it to surface treatment. Why? Because titanium is likely to undergo some unwanted properties, so it is to be coated with some alumina or some other ingredients, so that coated titanium oxide will have better solubility in most of the alkates or epoxies. Therefore, this surfactant treatment is essential, and after that, titanium is dried and packed into gunny bags. That is the final product of titanium dioxide. But this is an old process now. A new dynamic process has come up, which is known as chloride process. Write down. Write down, please. Chloride process. In this method, what I am talking, in chloride process, you get a uniform particle size. There are specific advantages. You get good brightness, whiteness, consistent particle size, and better control of the reaction. Better control of the reaction. Just see what is done here. Here, titanium dioxide, coke, is taken in a reactor. The temperature is raised to 950 degrees Celsius. Very high temperature is required, 950 degrees Celsius. Just see the equation. Read the equation and please write in your own handwriting. That will help you to remember. TiO2 plus 3C plus 4Cl2, that gives you 2TiCl4 plus 2CO plus C. We get titanyl chloride, but temperature is very high. The reaction, the main obstacle or main difficulty in processing ilmenite ore, temperature which is required. In other processes, you do not require such a high temperature, but here you have to go to a very, very high temperature of 950 degrees centigrade. And this titanyl chloride is such a thing that other chlorides, they are less volatile. Therefore, they are removed. When the vapors, the other impurities are automatically removed. And this chloride is then subjected to oxidation. TiCl4 plus O2, that gives you TiO2 plus 2Cl2. Again, this you have to conduct at very high temperature, that is 1000 degrees centigrade. 1000 degrees centigrade. But the advantage in the process is regeneration of chlorine. Means we have used chlorine, we have made our product, and while at the end of the process, this chlorine is again liberated. So you can recycle this chlorine. Recycled chlorine is very, very important because chlorine is a costly item, difficult to handle. So naturally, whatever we are using in first step, we are producing in the second step and again recycling it. So that is the biggest advantage of this process. Finally, we give surface treatment with aluminum, silicon, and zirconium. Oxides and hydroxides of alumina, silicon, and zirconium. Why this treatment is essential? Because our pigment should have better wettability, better emulsifiability with various binders with which you are using. Otherwise, it will remain insoluble. So this coating helps in dispersing the pigment quite easily in various binders. Nowadays, mostly this chloride process is practiced because it is simpler. It gives a more brilliant white color and uniform particle size. Particle size control is a little bit difficult in your sulfate process, while it is once you set up the conditions, you will get the exact particle size, whiteness, brilliance, and properties. So more common now today is chloride process. I think you have written everything. So once again, I will just tell you the steps in which it is made, so that it is, you understand it. So let not go to read again and again, just understand it. What you have to do, you have to take ilmenite ore, dry it, grind it, then mix, cook, and heat it at 950 degrees Celsius. Heat it at 950 degrees centigrade, pass chlorine, reaction takes place in which titanyl chloride, titanyl tetrachloride is produced, and other chlorides which there present as impurities, iron, silicon, or others, they are volatile. So they will be removed automatically. And this titanyl chloride solution, you react it with oxygen. Again at a very high temperature of 1000 degrees centigrade. So you get titanium dioxide plus chlorine. Okay. So then subject it to surface treatment. Why surface treatment is essential? Because we want to disperse the pigment in binder. Dispersion capacity is very important. Otherwise, it will have a tendency to separate out. So by having this coating, it goes very easily into the binder. Even if it is an emulsion, like your tractor acrylic emulsion or something like that, in emulsions also, the dispersibility by using these additives is improved. That is how we produce titanium dioxide. The second important thing which I want to tell you, that is about crystalline structure of anatase and rutile grades. Just go to that picture. Open your books or open your WhatsApp. There are two structures. It is the crystalline structure of anatase grade and rutile grade. Okay. What is happening, that titanium, the black spots indicate titanium and others represent oxygen. What is the structure of rutile grade? Try to understand here. The unit cell, the height of this cubical structure is 2.95 angstroms unit. If I compare this with the structure of anatase, we see that rutile grade has a more compact structure. The more closer the atoms, the less the light which will pass through them. In anatase, they are not packed very nicely. There is a space, more space, so light will enter into it, it can go off. Here, the unit cell is having a dimension of 3.78 and 9.49. But just by comparison, you can understand that the packing of atoms in rutile grade is more stronger. They are more closer. In fact, you should try to write down these structures with pen and pencil, rutile and screen is not sufficient. It is a homework that you draw rutile grade as well as anatase grade. When you draw a drawing, you will better understand the Do you open that page? Page open केला का?
Yes, sir.
हाँ. Now just compare rutile and anatase grade of pigment. Now you have already seen the crystalline structure of both rutile and anatase grade and how it is affecting the properties. It is very interesting to note. The rutile has slightly yellowish color. Rutile grade has slightly yellowish color, but if fluoride process is used, you get a brighter pigment compared to sulfate process. While anatase has cold bluish white color. Anatase has cold bluish white color. The specific gravity of rutile is 4 to 4.1, while that of anatase grade is 3.7 to 3.8. The dense packing in the molecule of rutile, you go to the crystalline structure. Because of the dense packing, the specific gravity of rutile is higher, while specific gravity of anatase is less. Oil absorption grams per 100 grams is, in case of rutile, it is 17 to 24, while in anatase, it is 19 to 22. Now here the fourth point is relative tint strength, capacity to change other colors to white. Suppose I take a black color, go on adding white, then tinting strength of rutile is higher, 1.2 to 1.4, while that of anatase is 1. Means for getting the same whiteness and brightness, rutile requirement is less, anatase will require more. Okay. Next point. Chalking is a phenomenon which I must explain you. Chalking means disintegration of the film. Titanium itself will accelerate the process of degeneration of the film. Because of the presence of titanium, the oxidation, titanium serves as a base or as a pull for reaction between your oil alkyd and oxygen. So binder will get degraded and a stage will come when by just with a finger touch you can remove the paint. That is known as chalking. You cannot 100% stop chalking because binder will go on degrading with time and depending on the condition, but you can protect it to some extent. By using some measures, you can protect the chalking property. In rutile case, the resistance to chalking is very good. Right down. For rutile grade, the resistance to chalking is very good, while in anatase it is very poor. Compare the refractive index. Refractive index of rutile is the highest, 2.71. Therefore, maximum hiding. While anatase grade has a refractive index of 2.55. Mean particle size 0.2 to 0.3 micrometers, while here it is 0.18 to 0.25 μm. Now you may ask the question that how to make rutile and how to make anatase. I have given you the manufacturing process. If I want rutile, then some seeding with rutile is essential. Means in the final stage, you add some crystals of rutile pigment. If you add those crystals, the whole thing will change to the rutile form. If you don't add rutile, then it will remain anatase. Another question which arises, if anatase has some disadvantage, then why to use anatase grade? Why not rutile only? The reason is, sometimes whether it is hospital equipment or somewhat bright white color requirement of the customer. Particularly, you must have seen that hospitals, equipments, walls, they are all painted white and very bright white. So there you have to use anatase. Or if you are making a white to car or white to your freezer or something like that, what you need is an anatase grade. Okay. Rutile is mostly used in industrial paints where durability, hiding power, shock resistance, all these things are very important. So in most of the industrial finishes, we are using rutile grade of titanium dioxide. Few things which still required to be mentioned, that is identification of TiO2. Suppose you get a mixture of pigments, whether titanium is present or not. Even if you, let us suppose that you join a paint factory and sample of titanium dioxide is coming from the factory. How to know in short whether titanium is present or not? Simple test is there, that on a tile where there is a small hole, you take small quantity of titanium dioxide, moisten it with sulfuric acid. Moisten it with sulfuric acid. Then add few drops of hydrogen peroxide. Then add few drops of hydrogen peroxide. You get orange or orange yellow color. If this color is there, that means titanium is present in your powder. If no coloration is there, that means titanium is not present. Very simple. On ordinary tile, if there is a hole in it, small gap is there, in that you add titanium. Add moisten it with sulfuric acid. And after making a small paste, add hydrogen peroxide. Color change will be there. And that color change is orange to orange yellow. That is known as testing or identification of titanium dioxide. The recent and very important development is spin drift, SPINDRIFT, spin drift titanium dioxide. What is this? I will try to explain. Spin drift titanium dioxide. Always remember that most of the pigments, they have a cluster of air around them. And because of the air, the scattering of light is better. So what we do, we cover this titanium air cover, we use polystyrene or copolymer of styrene to stop or to cover that air. If I had this cover, then scattering power of titanium goes on increasing. increasing, and you get better hiding, better reflectance, and brighter appearance. That means it is just like coating titanium particles having a surrounding of air with a polymer, like your styrene or copolymer styrene. That is known as spin drift. What is the advantage of spin drift? SPINDRIFT. Spin drift powder. It has got better scattering, better hiding, brilliant appearance. The cost is definitely more than normal titanium dioxide. So I think this finishes with my lecture on titanium dioxide. Now, as far as the industrial uses, you can write down the industrial uses of paint. Automotive paints, marine paints, hospital equipment, wall finishes, stoving paints. In all the sectors, anatase and rutile both are used. If there is a specification that you want bright white, then you can go for anatase grade. But most widely used pigment, almost all paints contain about 10 to 15% titanium dioxide. Means, in fact, paint industry is almost 50 to 70% dependent on titanium dioxide, and therefore it is a costly material available at 250 to 260 rupees per kg. And all paint manufacturers, small scale or large scale, they have to maintain a proper stock of titanium. But one very important practical difficulty which I have also faced, that traders do always mix titanium with something. Means they get from Travancore 100% pure titanium dioxide and then add 5 to 10% of calcium carbonate or calcium sulfate or something. Is it not? So it reduces the hiding power. And your consumption of titanium, it is very difficult to detect smaller percentages of these additives. So some paint manufacturers, they directly order truckloads from Travancore titanium powder. Direct truckloads from Travancore, that is almost pure. If you purchase it from local traders, they are bound to mix some extenders in it, whether it is calcium carbonate, calcium sulfate or something, some silicates or something like that. Because your extender is just 5 to 10 rupees per kg, while this titanium is 264 rupees per kg. I have worked practically in a paint factory, and to my worker, he was so smart that after making a paint, he used to tell me that titanium साहब अच्छा है नहीं है अच्छा. मैं पूछता था how do you know? It is very simple. बोले मैं क्या करता हूँ, ऐसा जो डोर था उसके ऊपर वो पेंट ब्रश जो है वो लेके और ऐसा लाइन मारता था. अगर लाइन एक लेवल तक जाती है वो तो इसका मतलब टिटेनियम ज्यादा है, और लाइन कम जाती है तो इसका क्या मतलब है कि हाइडिंग कम है. लोग बहुत ज्यादा एनालिटिकल टेस्टिंग करते नहीं है. ड्राइंग बोलो, ये बोलो, ड्राइंग भी ऐसा लगा के देखते हैं ब्रश से, ड्राई हो गया तो दैट इज ड्राइंग टाइम. यानी जितना अपन एनालिटिकल इसमें जाते हैं ना, स्मॉल स्केल में किसी को इतनी फुर्सत नहीं रहती. तो दे आर जस्ट डूइंग इट बाय प्रैक्टिस. और हाइडिंग पावर पर्टिकुलरली वो लोग जस्ट बाय ब्रशिंग. वॉल के ऊपर आप किसी भी पेंट फैक्ट्री में जाएंगे तो वॉल के ऊपर बहुत लाइंस दिखेंगे. तो पेंट बन गया कि पहला काम क्या करते हैं, वो डोर या वॉल के ऊपर ऐसा खींच के देते. अगर वो लाइन आखिर तक जाती है इसका मतलब पेंट अच्छा है, अगर वो हाफ तक जाती है तो इसका मतलब पेंट खराब. These are some practical things which if you join at all paint factory, then you will know that how to handle these problems. And titanium is very important product from the viewpoint of shade matching, because the larger companies, they buy directly from the manufacturers and in huge tonnage. So their quality of titanium is excellent. Small scale people, they cannot afford to buy huge quantity, and therefore their titanium is not pure. As titanium is not pure, they are not able to get paint of the same status which the Goodla's Nerolac or Asian paints are making. Still the two are working. It's not that it is impossible, because people who have shown very good in small scale industry. Even today, the small scale paint industry is around 20 to 25% of the total production. Particularly, most of the paint factories are located in Kanpur, Mumbai, Faridabad, and to some extent in Hyderabad. But large regions of the country don't have more number of paint factories. There is definite scope for going into this line, because the investment is smaller, manpower required is less. So at least 10 of our students, they have opened their own paint or ink factories. They are successful, and out of you, I hope one may be successful in this line also. Thank you very much. We will end up with few questions which you can ask.
Sir, spin drift titanium dioxide.
एक मिनिट, हाँ बोला.
Sir, spin
बोला
drift titanium dioxide.
हाँ हाँ. I have told you that all pigments are surrounded by a layer of air around them. Air has a refractive index of 1. Is it not?
Yes, sir.
Now, whatever hiding or brilliance or things which you are seeing, they are because of the difference in refractive index. Is it not? Now, what we try to do, we try to cover this air layer with a polymer. Polymer is copolymer of styrene. Means just coating the pigment with some selected polymers. So what will happen, that this coating is more or less transparent, but it will cover some air. Air is not free, but air is bound to pigment to some extent. And therefore, this particular system will have a greater reflectance. It can hide better, it can shine better in your development. And one more thing I will tell you, that whatever steps I have told you about titanium, that there is a scope for improving the titanium dioxide manufacture technology. The plants are very huge, the expenses are in millions of dollars. One titanium factory will cost you a huge capital investment. So you can think of some process by which you can manufacture in a simpler way. Of course, nobody has tried it up till now, but you are there to try it. One experiment, one of the students, we have given him a project. There is in aluminum plant, there is a slag, which is a waste material. That slag contains about 13% titanium. So we have taken that slag, purified it, and made paints out of it. So there are some industrial waste in which we have got some titanium. There are huge number of aluminum plants, and this aluminum slag has got 10 to 13% titanium. So this is one of the ways. We have done some work on this line. Prajwal, any question?
So in the surface treatment, what kind of surface treatments are there? I mean, does it only adsorption or?
I am not listening properly. Just you speak once again.
So what are the surface treatments? The surface treatment which is being mentioned in the sulfate process as well as in the chloride process. So what does these processes are? Exactly what do we do in surface treatment?
Actually, I am not listening properly to you. Just a minute. I will try to correct myself. हाँ, आता बोल बरं.
So surface treatment exactly काय आहेत म्हणजे we are
हाँ
carrying out
हाँ.
surface
हे
treatments
पहा,
in the state as well
अगदी
as
तुला साध्या भाषेत सांगतो की डायरेक्टली टिटेनियम बनवलं. त्याला तुम्ही ऑइल किंवा बाइंडर मध्ये टाकलं ते भिजणारच नाही. त्याची टेंडन्सी काय राहील, वर वर जायचं. That surface is not ready to accept easily the binder. Okay, so what we do, we make some coating around that pigment. That coating will make it vulnerable to go towards vehicle. Easy dispersion, easy mixing, easy emulsification. All these properties you can get by having a coating of oxides, zirconium oxide or aluminum oxide or something like that. Anything else?
Sir, chalking process.
I will explain once more the chalking process. In chalking, what happens that you apply a coat of the film. Okay, so titanium, when present in the film, it has a capacity by when ultraviolet reaches to it and binder is there. So that process is enhanced by use of titanium. Suppose I take anatase grade pigment, that anatase grade pigment is attacked by ultraviolet light, it creates free radicals and it accelerates the process of decomposition of binder. And what happens that if it attacks the surface, then if you apply a finger on the wall, the paint will come out. जैसे आपका सिंपल चूना लगाते हैं तो ऐसा चूना लगाना ये तो मालूम है सबको, है ना. तो वो ऐसा उंगली से लिए तो वो निकल जाता है ना. तो वो कंडीशन आना है ना चॉकिंग. या चॉक से लिखते हैं तो थोड़ा नीचे गिर जाता है. क्यों गिर जाता है? क्योंकि बाइंडिंग पुअर हो जाता है. बाइंडिंग पुअर होना इसका मतलब पेंट निकल रहा है. और ये चॉकिंग का प्रोसेस टिटेनियम की वजह से फास्टर हो सकता है एनाटेज ग्रेड की वजह से. तो इसके लिए क्या करना पड़ता है? उसको ट्रीट करना पड़ता है. ट्रीट करने से क्या होता है कि जो कुछ एसिड्स जो रिलीज होते हैं वो एब्जॉर्ब कर लेता है वो, तो वो फिर फर्दर डिजेनरेशन नहीं होता. दैट इज हाउ वी प्रोटेक्ट टिटेनियम.
सर हेलो.
हाँ बोला.
सर रेजिस्टेंस टू चॉकिंग एनाटेज की कम है आपने बताया. रेजिस्टेंस टू चॉकिंग एनाटेज की कम है.
Rutile grade has less chalking tendency. For 5 to 10 years, rutile grade will not undergo chalking, but anatase can undergo chalking within a year or two.
Yes sir, yes sir. Sir, लेकिन
yet those who are interested in extreme white shades, they will still go for it. They will say we will coat it after 1 to 2 years.
सर तो एनाटेज की प्रॉपर्टी को ये थोड़ा एनहांस करने के लिए कुछ कर सकते हैं क्या? चॉकिंग के रेजिस्टेंस बढ़ाने के लिए कुछ कर सकते हैं?
चॉकिंग के लिए ये मैंने जो बताया वो कोटिंग प्रोसेस करते हैं ना, उसके बाद अभी जो मार्केट में टिटेनियम पिगमेंट्स आ रहे हैं they have extremely good chalking resistance.
एनाटेज में भी
हाँ ना, एनाटेज में तो कम रहेगा, बिकॉज नेचुरली एनाटेज ग्रेड का स्ट्रक्चर जो है, क्रिस्टल स्ट्रक्चर, वो ऐसा है कि इट प्रमोट्स ऑक्सीडेशन, अल्ट्रावायलेट एब्जॉर्प्शन और फ्री रेडिकल्स क्रिएट करना, ये उसका बेसिक नेचर है. फिर भी वो भी बहुत पुअर ग्रेड्स नहीं है. एनाटेज में भी अभी ऐसी चीजें आ गई हैं कि 2-3 साल तक कुछ नहीं होता. Means already developments are there in every field and you can get very good materials.
ओके सर, थैंक यू सर.
Thank you. So I think
Sir,
we finish
sir.
up here. Yes.
Hello.
हाँ.
Sir, why titanium oxide obtained from chloride process is more beneficial than sulfide process?
Yes, definitely. Just try to understand the process. The chlorine is regenerated. Whatever chlorine you are using, it is not wasted. जैसे सल्फ्यूरिक एसिड से ट्रीट किया या किसी एसिड से ट्रीट किया तो वो सल्फेट तो फेंक देना पड़ता आपको, जबकि यहाँ पे क्लोरीन यूज कर रहे हैं. वो क्लोरीन एक बार यूज हो गई तो पूरी की पूरी रीयूज हो सकती है. और इम्प्यूरिटीज जो है वो बहुत ज्यादा वोलेटाइल रहती है. क्लोराइड्स आर मोर वोलेटाइल. तो टिटेनाइल क्लोराइड जो है वो उतना वोलेटाइल नहीं रहता, तो बाकी चीजें ऑटोमेटिकली निकल जाती है, इवन इन ट्रेस क्वांटिटी. दैट इज हाउ इट वर्क्स. So I think we conclude here, and tomorrow we will meet again at 12 p.m. I think Friday, Saturday, Sunday is a good option. Whether you like
Yes,
it or not,
sir.
क्या है बोलो?
Yes, sir.
Yes, sir.
Yes, sir.
Because continuity is one very important aspect. एक दिन पीरियड लिया फिर 2 दिन नहीं लिया तो पहले क्या कहा था उससे वो कोरिलेट नहीं होता कुछ भी. So we meet on Friday, Saturday and Sunday. That is the best way to work. I think with this speed we can finish our course within 1 month. It will take 1 month and you will be able to, and you should score the best in this examination. That is what I expect. Because if you get poor marks, that means your teacher is poor. Your marks will indicate whether I am successful in my work or not. If you get good marks, then I am a good teacher. If you get bad marks, that means I am a bad teacher. Okay? Thank you very much.
Thank you, sir. Thank you so much.
Okay.
थैंक यू सर.
Thank you, sir.
Hmm.